Alright, next we have 1.1. We're going to be doing this in a couple parts. So this is going to be 1.1 part 1. In the first ones, we have our vocabulary, relation, function. Set A is called the domain. We're going to put some more words in here. The independent, also known as the x values. Whereas set B is the dependent. It is the range, also known as the y values. Alright, this down here representing a function in our 4 ways, this is exactly what we've been talking about continuously, and that's our NAW process, where we have graph, numeric, algebraic, and in words. And we just talked about x being the independent, y being the dependent. So do these represent y as a function? First thing you need to do is you need to solve for the y value. We're going to subtract the x squared over. We should know that an x squared is a parabola, and a negative means that it is going to go downwards. But we do know that our vertical line test, this is something that we ran several times last year when we talked about functions. Our vertical line is that it can only touch every point one time. And we do get to say, yes, it is a function. On the next one here, we get y squared is x plus 3. So y is the plus or minus square root of x plus 3. When we talk about a square root, we do get a kind of a shaped type of picture, and we just know that from a basic sense. Well, the negative part of it goes downwards, so when I run a vertical line test, no, it does not pass for the vertical line test. We can put that into our calculator as well to verify that, but we should know these basic shapes from previous. Alright, on page 2, function notation. This should be a review as well. We were introduced to this last year. If we have an input value of an x, we have an output value of f of x, where f of x actually represents our y value. It's just a new way to write our same equations. It's just we're going to use function notation, f of x, where we have f of x equals some kind of an equation. And when we test, this is nothing more than a substitution. I'm going to put the x value in, or negative 1 into the x value. So 3 minus negative 1 squared. So I get 3 minus 1 for 2. Then I'm going to test it for 0. And then I'm going to test it for 2. So 3 minus 0, we get 3. 3 minus 4, we get negative 1. We can use different letters. They all mean the same function notation. Once you put it into this kind of some letter, this might be the I don't know, whatever G and S could stand for, grams per second. You know, but generally whatever's inside here is going to be that independent x value, and the whole thing represents that output, that y value. So evaluating is the exact same thing as testing. When we test for numbers, we generally don't have too many issues. So when I say g of 2, we can usually not have too many issues, and we put 2 into the x location. So we just replace the x with the 2 and simplify. So we get 7. So we would say g of 2 is 7. We'd say when the x is 2, the y value is 7. On a picture, when the x value is 2, the y value is 7. That's all that represents. All right, when I'm putting in a letter, it makes no difference. You're doing the exact same thing. This is my substitution. T is my substitution. So wherever there is an x value, I'm going to put a t value. For the moment, I'm just, there we go. So there was an x, I put a t. There was an x, I put a t. And that's all we have here. Negative t squared plus 5t plus 1. We just made it a letter instead of a number. The numbers simplified down. The letters do not. We don't do anything different. So when we have a actual equation or polynomial, we still don't change anything. Everything that's in the parenthesis goes into the x location. I'm going to come down here with this. So negative, I had an x, but I'm substituting not the 2 like I did in the first one, t like I did in the second one. So in the third one, I'm substituting an x plus 2. Then I have plus 5x. Well, in the first one, instead of x, I put 2. In the second one, instead of an x, I put t. So in the third one, instead of an x, I have x plus 2. And then the plus 1. Now I need to simplify this down. The square says I have 2 of those. So that's really going to be x squared plus 4x plus 4. I get to distribute. I have to distribute this negative sign. And then I'm going to combine all my like terms. Negative x squared plus x, and then plus 7. Alright, so this g of x plus 2 is really that leftover. G of t and then we have g of 2. Oops, I picked out the wrong one. G of 2. Okay, so now we're moving on to the piecewise defined function. We're going to evaluate the function when x is negative 1, 0, and 1. This piecewise, what it means is that my graph is broken into different sections. For x squared plus 1, my x is less than 0, and for x squared minus 1, we're going to just look at x squared is greater than or equal to 0. So when I'm saying x is negative 1, well, that's less than 0, so I'm going to be using only the top function to evaluate, only the top function to substitute into. So I get 1 plus 1 is 2. When I look at 0, well, that's equal to, so that means 0 is only going to be using the second function. X squared minus 1, 0 minus 1 is negative 1. And then if I have the value of 1, when x is 1, uses also this second equation. So x squared minus 1, 1 squared minus 1 is 0. So all this is just determining which piece of the function you're going to use. There's more than one piece to the function, and you're going to use whichever one this falls into, whichever category that it falls into, whichever stipulation that it falls under. But it's the pieces that you are going to be substituting into. Not both of them, just whichever one satisfies it. Going to end part 1 of 1.1.